afternoon. This is Sirme, your tutor in YouTube, Dr. Sirme, and a virtual tutor through Zoom. And as well, we are now doing our live Facebook. Now, we are going to do quadratic expression. Quadratic expression. And this is a topic that is covered in Form 2 and it's also covered in Form 3. Now, we start by asking ourselves, why is it called quad? You know, anytime there is that term quad in mathematics, basically it has something to do with 4. Like a quadrilateral. A quadrilateral, that is a four-sided plane figure. So what is the connection between this quadratic expression and a four-sided plane figure? Let's take for example, that is a rectangle. That's a rectangle. And this side is x plus 3. And this side is x plus 2. So these are the two dimensions of this quadrilateral. So what I can say, I can subdivide it. The value of this point is x, then the remaining here is 3. Okay, then I can subdivide it this way. Yes, the value here is x, and of course this one is 2. So if I'm to find the area, I'm interested with the area. The area of a rectangle is length times width. So like with my case here, it would be my length x plus 3 and the width, that is x plus 2. With that, I can now go ahead and work it out. Remember, the area, I can just multiply this using what we're calling the quadratic expansion, like we are going to see later. Otherwise, I can work it from here. I have area A, area B, area C and D. I can work them out. The area A is x squared. The other area here, remember this is x and this is 3. It is 3 times x. So the area B. The area C, it is 2 times x. It is 2 times x, 2x. The area D will be given by 2 times 3. 2 times 3, 6. So otherwise the area will be x squared plus 5x plus 6. I have an expression there that represents the area of the quadrilateral, the area of the rectangle. And that's why these expressions are basically called quadratic expressions. Quadratic expression. These are expressions that represent the area of a quadrilateral. A rectangle for that matter in this case. That means I can simply state that x plus 3 multiplied by x plus 2 is equals to this. So even without the area of a rectangle, I can still work it out. I can take x, then I multiply by this factor, x plus 2. Yes, then I take the 3, I multiply by the same factor. With that, I have x squared. Opening the bracket, this will be 2x. Open this bracket, this will be 3x. Open this bracket, this will be 6. And finally, this will be x squared plus 5x plus 6. So the very same thing is obtained there. So quadratic expressions, these are simply algebraic expressions that represent the area of a quadrilateral or a four-sided plane figure. So if, for example, I have a square, not necessarily a rectangle, the story is the same. So if I'm working with a square, this is a square, wow, it is more or less of a rectangle, that's a square, and maybe this is x plus 3, and this is x plus 3. So just like I did, this can be the x, this is 3. Over here, this is x here, this is 3. So I can find the area. So x plus 3 squared, the area of a square, length, squared. So this will simply be x squared here. Then this one will be 3 times x. Remember, this is 3 times x. So 3x. That is the first one. The second one we have. The third one here will be 3 times x again, 3x. And then this one will be 3, and this is 3. 9. So this will be x squared plus 6x plus 9. Actually, this one, as we are going to see later, like it is covered in Form 3, this is a perfect square. And what do I mean by a perfect square? It represents the area of a square. It represents the area of a square. And that one is covered in Form 3 in detail. Basically, in this case, maybe we do more what we call expansion. That is expanding. So what we're doing is expanding. Expanding is basically finding the area of the rectangle or the square, for that matter. X, for example, plus 5 multiplied by x, maybe plus 6. So how do you go about that? Like I've done with the other one, this will be x times the whole of this factor, that is x plus 6. Then I take the 5, I multiply by the same, x plus 6. What I'm doing is what we call expansion. We are expanding. So x squared, x and 6, this will be 6x, this will be 5x, and this will be 30. The like terms together, this will be x squared plus 11x plus 30. So that is the expanded form of the equation, the factors you have there. The factors you have there. Maybe we can do one more without necessarily going to a quadratic square or a quadrilateral there. So we can expand one like with a negative. Like I can have y minus 6. Yes. I can also have maybe y plus 7. Like that one. I'm trying to expand. The very same story. This is y multiplied by the whole of this factor. Then negative 6, it's here. Y plus 7. Then you open the bracket. This will be y squared. 7y. This one is 6y. And then this one is minus. Minus times positive. That's negative times positive. You get negative 42. With that, this will be y squared. 7 minus 6. 7 minus 6 is simply 1. 1y minus 42. That one again is the expanded form of that. Good. With that, we have done the first part of quadratic expression that you should know. It's what is called expansion. Maybe one shortcut you should know that is not necessarily of two different factors. It's what we call quadratic identities. Quadratic identities. These are like shortcuts that we use. If I'm given a factor that looks like this, a and b, whatever a may be and b may be, if I'm given this, in short, I need to do a squared. The first factor here, if it was 2x, it would be that 2x squared. Of course, whatever was here, if this one was 2x, this was maybe 3, then the other factor here will be treated as 3 and this is 2x. So then the next one will be that is twice AB. Twice AB, then B squared. I know that one I've done it very fast. I can do an example that you may understand. For example, if I have that. I need to use the quadratic identity. First of all, I can use the longer method. Or rather, let me start by the identity. It states that it is a squared, x squared, plus x times 3 times 2. That is 3x times 2, 6x, plus then 3 squared, that is 9. I think that one we had in one of the square we had before, and that is it. So if I'm to do with the longer way, it will be x plus 3, x plus 3. So with that, I can take x plus 3, then it will be 3x plus 3. Good. Thank you. This one will simply be x squared plus 3x plus another 3x plus 9. 3 times 3. So if I summarize this or I put the x's together, I'll go back to that. So this is a shortcut. Quadratic identity 1. The first quadratic identities we use, the shortcuts is you do expansion. When you are doing expansion, we have a shortcut. So if I'm given a minus b, this one again squared, this one again we do a squared, the a squared, a times negative b times 2, that will be 2ab, then negative b squared. That. So this is the second shortcut of quadratic identity. The third one, a plus b and a minus b. If I'm given the 2, this one will give me a squared and minus b squared. So this is the third quadratic identity. And for this one, maybe no need to maybe prove them. They are called quadratic identities. They are shortcuts. These are shortcuts of expanding some quadratic identities expression. Not all of them, just some few. Good. Tumefanya nini? Expand. So we want to factorize, to do the reverse. We want to do just the reverse of that. And that one now will call for us now to get more examples. I hope my students, those who are following, I hope you're getting it. You're getting this mathematics. And for the parents, we do make very huge investments with education. So I think it is one area we cannot ignore. It's one area concerning our students and our children we cannot ignore. So what we want to do is now factorizing. This one, factorization. We want to do factorization. Let me get an example now. Let me get an example from my small book here. Maybe the question is x squared plus 9x plus 20. You are asked to factorize this expression. You're supposed to find the factors that were multiplied to get this. It's like you have the area of a quadrilateral, like a rectangle. Now you want to find the length of this, the size of the length and the width. So with this, what do? This one is called the first term. This is called the second term, and this is called the third term, or the constant. And what I need to do for a start, I need to look for two integers, m and n, such that if I multiply them, the product will be the third term, or the constant. And if I add them, I will get the second term, or the coefficient of the second term, 9. So which are these two factors? If I multiply them, I get 20. If I add them, I get this. Good. You know the factors of 20. 20 has factors 1, 2, 4, 5. It has 10 and itself. So which are these two factors? If you multiply them, you get 9, or you get 20. You add them, you get 9. So the factors, there they are. Remember, the other factors will be 2 and 10. The other one will be this. So you take this. So the m and n that we're looking for, it is a 5 and a 4. So what do I do with this? I express the second term using the two factors. How will I do that? I will do x squared plus 5x plus 4x. Remember, what I've done is just to write this 9x in this expanded form, then plus 20. Then I group into two, this and this. Yup. I think these credits I take it to my former teacher. That guy was called Mr. Gishiro. May he rest in peace. The guy who taught me even quadratic expressions in Form 2 very many years ago. So this is x. Now I am factorizing at this stage. So x and x are common in this case, so it is x. So plus 5. Remember the x here is factored out. We have factored that out. So then you come to this one. 4x and 20. What is the common factor in that? 4 is common. Actually, 20 is a multiple of 4. So what I'll do, I'll factor out 4. I factor out 4, x remains, then 5 in there. Remember, this area and this area must be the same. They must be equal. And if they are equal, now we need to factor them out. This is the same, this is the same. It's like I'm talking about xm and 4m. Look at that. I need to factor out m. M outside, then the other one wakae ndani. So what was m? I represented this with m, 5x plus 5. So then this is x plus 4. And I have done what is called factorization. I have factorized the expression by factorization method, and I have come up with the final factors. Good. I hope you have it. You're copying it very fast. Those who are following, and I erase. And as we do one more example and the last one, and we do one and the last one. Good. I can have one. I want to do a more complicated one. This is x squared plus 11x plus 12. So if we are doing this one, again, this is the third term or the constant, second term and first term. If you consider this, the coefficient of the first term is not 1. So we cannot go direct looking for integers that gives us this as the multiple. What we do multiply the coefficient of the x squared with the c. So what you do, the product should be a, whatever this is here is usually called a times c first. Should be a times c. So like in this case, it will be 2 times 12. So I'm looking for two numbers. Their product is 24. The sum should be the same, 11. So which are these two factors? Multiples of 24. 24 can be divided by 1, by 2, by 3, by 4, by 6, by 8. Yeah, it can go by 12 and by itself. So we're looking for factors. So 24 and 1 goes 2 and 12, 8 and 3, this and this. Which pair gives us 11? So if you add like 4 and 6 to give us 10, not 11. So but 3 and 8. So the factors we're looking for, the m and n is simply 3 and 8. 3 and 8. Like I did before, it will be 2x squared plus 3x, yeah, plus 8x. What I have done here, it is the same. Just expanding the 11x to it and write it in this form. Then this one will be plus 12. Yes, plus 12. I pair this and I pair this. So what is common here? X is common. X is common. Yeah. X is common. If X is common, then ndani kuna baki nini? Wait. Hi, X iko nje. 2x remains inside. So over here, only 3 remains inside. Good. That is it. Then we come here. 8x, 12. What is common? 4 is common. It's a common factor. So you factor it out. Then inside will be 2x plus 3. Remember now, if you factor out 4, 3 will remain here. Like I said before, these and these are the same. They are very much equal. I remember my teacher telling me, if you fall in love with the two twins, you just take one. That was Mr. Mutegi many years ago again. So I'll take 2x plus 3. Then x plus 4 remains outside. So this is the factor. This is the factors for the form, or rather the expression we had before. Maybe next, I will be doing quadratic equations, solving quadratic equations. But this was all about quadratic expressions. And this is your tutor. And we are doing a lesson at 3. We are having a virtual lesson at 3 over this board, the very same board with some students. So I'm welcoming you. I'm inviting your student for the Zoom class. Yeah, the Zoom class. It will be over here. We'll be doing chemistry, and I'm sure your student will benefit. Do not forget, we have a YouTube channel, Dr. Sirme, Dr. Sirme, the chemistry master. And that's where we get to learn a lot of chemistry. We can't let our students go to our waste. We can't let the dreams they have to be doctors, engineers, and many other good professions they want to be. We can't let it go to our waste because we are here to help them. Ourselves, we did very well, and we decided to be teachers so that we can help your students. We can help your children. Otherwise, that was the lesson of the day. And do not forget, kindly link with me directly, and I'll send you the link that will make you student now join our class. Thank you, and thank you so much. Kindly subscribe to this channel, recommend to a friend, and do not forget to come back for more. Goodbye.